Hello, Warhawks. This is Mr. Tipton. Let's do some tangent lines from Chapter 11. We may remember tangent lines are lines that just touch the circle one time, that just barely touch it. So here we have some tangent lines. Now, this would not be an example of a tangent line that I just drew there, because what you see is if I continue to extend that line, it would actually pass through the circle. And we don't want that. We want tangent lines just to touch the circle and then continue to go off and never touch the circle again. So these are tangent lines. They just barely touch the circle at one place. Here's something that's important to know about tangent lines. Where tangent lines intersect, so here's two tangent lines. This is the point where they intersect at. They are equidistant from the circle, so from right there and right there. It's going to be equidistant to the point of intersection. So those two are going to be congruent to each other. So like if this was 14, this would be 14. So from the point of intersection to where they touch the circle, tangent lines are congruent. Equidistant is the word that we used here, which just means the same distance. Let's look at an example here. So they've given us some tangent lines. These are all tangent lines. You see that line only touches there. That line only touches there, and when we touch right there. So if we look at this, what they want us to figure out is what the perimeter of this shape is. So we just learned that from where tangent lines intersect to where they touch the circle are going to be exactly the same. So if this is 5, then this has to be 5. They must be the same. Now, a lot of times people want to say if this is 5, then this is 5, but that doesn't fit our definition. Tangent lines are congruent from where they touch the circle to where they intersect. Notice how this line is the same tangent line as that line. So we want intersecting tangent lines are going to be congruent. So that 5 and that 5 are congruent. Well, if this is 7, we also know that this has to be 7, because these two tangent lines intersect here, and from where they touch the circle to where they intersect is an equidistant. So if that's 7, that's got to be 7. Down here we see another one that's 9. If this length is 9, this tangent line intersects this tangent line right there. So from the circle to where they intersect is going to be congruent. So if we wanted to find the perimeter of this, we would add up the sides. This side has a length of 12. This side has a length of 16. And this side has a length of 14. So we take those side lengths and add them together. 14 plus 16 is 30, plus 12 is 42. So the perimeter of this triangle would be 42 units. We use the tangent lines to help us find that. Let's look at another example where we want to find the perimeter. So this one, they've given us some different things. There are a couple things I know here. First of all, that tangent line intersects the circle there. This tangent line intersects the circle right there. So from where they intersect the circle to where they intersect each other are going to be the same. So if this length is 6, this length also has to be 6. Now they didn't give me anything up here, but they did tell me that this whole side was 14. Well, if this part's 6 and the whole thing's 14, then this would have to be 8. And actually, let's just change the measurement here so we don't get confused. Let's change this to a 9. So here we have that this is 6, the whole thing was 14, so this is 8. Now again, here's a tangent line, here's a tangent line. These two tangent lines intersect right there. So from the circle to where they intersect is going to be the same distance. So that also has to be 8, because that was 8. We found that from subtracting 6 from 14. And the last thing we have here to find is this. Now, a lot of people want to make this 6, but again, this tangent line and this tangent line intersect right there. So from the circle to where they intersect is the same distance. So this length is 9, which means this length also must be 9. Let's find the perimeter. So this whole side was 14. So the perimeter is going to equal 14 plus this whole side is 17 plus this whole side, which would be 6 plus 9, or 15. We add those together. 14 plus 17 is 31, plus 15, we get a perimeter of 46 units. Now let's look at the last thing that tangent lines do. So here we see a tangent line. It just touches the circle one time right there. And when you have a tangent line, a radius, which is what this is right here, makes a 90-degree angle with the tangent line. So here we see a 90-degree angle, the tangent line and the radius. Now notice how this is not a tangent line because it goes through the circle, and if we extended it, it would touch the circle again. That would actually be a secant line. Here's the center of the circle. So this is not a 90-degree angle here. It's where the tangent line and it's where the radius touch is going to be 90 degrees. So think about what type of a triangle this creates. It creates a right triangle, which means that I could use Pythagorean theorem to solve for a missing side. Now, one tricky thing here is this, that most people forget. 7 is the length that's outside of the circle here. Now, it might change on different questions, but this is 7. This whole side isn't 7. We know that radii are exactly the same. So if this radius is 5, that means that this length has to also be 5, making that whole side really equal to 12. Okay, but you had to know that all radii are congruent. If I drew one here, it'd be 5. If I drew one here, it'd be 5. If I drew one here, it'd be 5. So now we can set up Pythagorean theorem to solve for a missing side of a tangent line. So we're going to do a squared, which I would say is 5 squared, plus b squared, which is this side, which is going to be x squared. And that's going to equal c squared, which is the hypotenuse. Remember, still, the longest side is going to be right here. So 7 and 5 make 12. So we're going to square 12. 5 times 5 is 25. X squared, we just leave it. And then 12 squared is 144. Now what we have to do is get x by itself. So remember, we should get an answer that's less than the hypotenuse here. I'm going to subtract 25 from both sides. Oops, it's very ugly 25 there. What I get when I subtract 144 minus 25 equals 119. So I'm left with x squared equals 119. Ugh, having some trouble writing here. And then to get that answer, I just take the square root of 119, which is going to be close to 11, but it's 10.9 is the length of that tangent line segment there that touches that. Okay, so remember, tangent lines create a right angle with a radius, which would then create a right triangle if I drew in the other parts. We'll see you in